Today we will start the new chapter number 1, that is the electrochemistry. The first topic we have to understand is the ion solvent interactions. Before going into the ion solvent interactions, first we will define some of the terms here. First we know what is the proper definition of electrolyte here. Basically, electrolytes may be defined as a class of compounds which, upon dissolution, in a polar solvent, dissociate at least partially into ions. So we can distinguish two types of electrolytes, basically two types here. First one, that is called a true electrolyte. So this true electrolyte is simply an electrolyte which dissociates completely, into ions. Next type, that is called as potential electrolyte. Okay, potential electrolyte. So this potential electrolyte has only limited dissociation. Based on these definitions, for example, if we take simple examples like NaCl, sodium chloride, this will be simply a true electrolyte. And if we take the example of acetic acid here, this will be simply a potential electrolyte. Okay, now first we will see what are basically the what is basically an electrochemical system. An electrochemical system. This basically includes two interfaces electronic conductors and ionic conductor. With the help of this schematic diagram, we will try to understand this. For example, you can imagine first, suppose this is an electronic conductor. That means through which electrons can flow. Okay. Next, this is in connection with basically this ionic conductor. And this side also we have one more electronic conductor. These two electronic conductors are connected to the external source or external electron source, you can say. External electron source. Or you can simply say sink. Okay, now this ionic conductor is basically separated from or is in contact with these electronic conductors, and this will be simply the interface. So this is the interface That means the surface which separates ionic conductor from electronic conductor. Interface. Okay, so this is also the interface. This is actually only one surface. That means the surface which separates ionic conductor from the electronic conductor. You can take the simple example which you have already learned. uh, for example this is an metal strip or electrode, you can say, and it is in contact with the ionic solution or electrolyte, that is ionic conductor. So this is the surface basically which separates this ionic conductor, that means this electrolyte, from the electronic conductor, this metal strip. So you can imagine these two electronic conductors as two metal strips, and this is the electrolyte, ionic conductor. Okay, so these are the essential parts of an electrochemical system. That means two interfaces, two electronic conductors, and ionic conductor. Okay, now the question is how one produces mobile. Question is how does one produce a medium of mobile ions, or how the ions are produced. Now we have one method which is based on the fact that certain substances which in the pure form, they basically do not contain any significant concentration of ions, and they simply interact with solvent or other entity to produce the ions. Okay, we can take the example here. Take an example. For example, we have a neutral or that is an non-ionic molecules of suppose water molecule and this acetic acid molecule. In pure form they are neutral. Okay, now when you mix the two, for example this acetic acid plus neutral molecule of water, these are just two lone pair of electrons here. One is here, one is here. So what happens, simply this proton will go here. Okay, so this is just a proton transfer reaction. and this results into the formation of the state ion, and it can resonate, and I will show you just the negative sign here. It can resonate. One time the negative charge will be on this oxygen and the second time on this. So simply you can write it as, that means this is simply an state ion plus hydrogen ion, and that means it will be shown like this as hydronium ion. This is simply a hydrogen ion. So here you have seen that two neutral molecules, they interact basically to produce ions. So this is one method of producing the ions. Now what about crystals, okay, or solids? So there are two distinct ways in which the interionic forces in a, we are taking now a crystal, suppose in a crystal can be overcome. The method one is simply, suppose you have a solid crystal, solid, what we are doing, just agitational, we are adding an agitational effect. That means we are basically heating or giving heating or heat energy to this system. You can say heat energy is applied. So this basically this increases the tempo of the ionic vibrations. That means as you increase the heat energy, obviously if these will be the ions, I will show you just by a schematic diagram. If suppose these are the ions in a crystal lattice, and when you increase, their vibrational energy will increase at their lattice points there. So ultimately what will happen, these ionic vibrations, that means this should be an ionic crystal first. For example, if we take the NaCl or something like that crystal which is in ionic form also in the solid state. So what will this heat energy do? It will increase the ionic vibrations until thermal forces basically prevail and the long range order of ionic arrangement in the crystal, basically in the crystal, but lattice is broken down or wiped out. What will this do? It will simply produce the ionic crystal. The ionic crystal simply melts, you can say. The ionic crystal melts. So that means if it melts, that means we got the basically pure liquid electrolyte. That means we obtain simply a pure liquid electrolyte having positive and negative ions. So this is the one method, just by supplying the heat energy, so it will simply melt the crystal and we will get a pure liquid electrolyte, and thus we can get the ions. One more method is simply by dissolving in a solvent. So the second method, basically another way of overcoming the inter-ionic forces in an ionic crystal. And simply, what is our main aim? To producing mobile ions. So what we will use? We will simply use the solvent. That means with the aid of solvent we will just produce these mobile ions. A simple example we can quote here. For example, a crystal of potassium chloride, or you can say KCl, is simply placed in water. What you observe after some time, when you take a crystal of KCl and put it in water, what will happen? Basically this crystal, it disappears. This crystal as an entity has disappeared. Then we simply put it into the water. That means what has solvent done? Solvent has this is called antacid. Solvent has antacid the ions of the solid, or produced the ions of the solid, you can see. This way dissolution of an ionic crystal takes place. We can quote a simple example also. For example, you can also take a sodium chloride crystal as well. I have already shown you a figure in the above discussion, so I will go back to that figure here. This is basically the crystal of NaCl, sodium chloride crystal. These are just water molecules. You know, water molecule is drawn in this way. This is delta positive, this is delta positive, this will be delta negative. Okay, that means, so we actually can draw this water molecule as a dipole. So we are having basically two negative charges, partial, and this part will be positive, this is also positive. So this way, or sometimes simply we draw this as a dipole, that means positive and negative. So remember, this is just a water molecule. Here this is water molecule. Okay, so what is this? Water acts as a solvent, so it can interact with the, suppose, the negative part of ions and cause their dissolution, or this is called simply solvation. Here you are seeing the Cl negative ion, and it is surrounded by the dipoles of water. That means this will be simply the solvated chloride ion. Similarly, you will see here the dissolution of Na positive ion, or solvation of Na positive ion, by simply this water molecules. So it is, you can also draw these in this way also. Suppose if we have a chloride negative ion, we can draw the dipoles around it. So obviously, if the central ion is negatively charged, so it will attract the positive part of the dipole. Okay, this will be negative, and so on. Negative, and this is positive and negative. So similarly, this Na positive, if you have Na positive in the center, that means it is positively charged ion. It will be surrounded by the dipoles of water molecule, but this time the negative end of the dipole will be towards the Na positive. So you can draw this in this way: negative positive, negative positive, and okay. So what is this? Basically NaCl. It is an ionic compound consisting of Na positive and Cl negative ions joined together via electrovalent bonds in a crystal lattice. This figure, what you are seeing here, which is just a crystal lattice. When this solid NaCl is put in contact with the solvent, such as this water, the solvent molecules, they basically rapidly attack the lattice, disrupt and break the ionic bonds, and thus generate hydrated ions. These are also written as, suppose if Cl negative in, you can write it as aqueous, that means it is a hydrated chloride ion, or Na positive aqueous hydrated sodium positive ion. So this is just the dissolution of crystal by action of solvent. So these were some of the terms which you should know before going into the ion solvent interactions. Okay, thank you.